Hi everyone, welcome back. This is the second part of the lessons on differential equations. So we've got a different sort of equation here. It's still a first order differential equation, but instead of dy dx being given as a function involving x, this time it's being given as a function involving y. So now we have to do a little bit more preparation before we solve by integration. So like we did last time, we want to get everything with y's and dy's on one side and everything with x's or dx's on the other side. We call this step the separation of the variables. So I'll leave my dy where it is, and I'll leave that little 3 where it is. What if I divide by y and multiply by dx? That looks like the variables are separated now. So I will integrate both sides. Now the integral of 1 over y with respect to y is the natural log of y. The integral of 3 is 3x plus a constant of integration. Writing this in exponent form, we would see that y equals e to the power of 3x plus c. Now when we do these and we end up with the constant as part of an exponent, it's more typical to write this as e to the power of c multiplied by e to the power of 3x using our exponent rules. And e to the power of c, well, that's really just some different constant, and typically it's called y naught. Now why would it be given the figure y naught? Well, let's think about it. If x equaled 0, then from this step here we would have that y equaled e to the power of c multiplied by e to the power of 0, which is really just e to the power of c. In other words, when x equals 0, we're talking about the initial value of the y variable. And I did give a little extra hint up here, didn't I? Given that y naught equals, when x equals 0, y equals 4, we could then write the specific solution of this as 4 e to the power of 3x. This is a general solution because we don't know the value of y naught, the original value of the y variable. Given the extra little fact, we could write a specific solution for this one. So that's how you solve a differential equation where we've got a function of y instead of a function of x. Remember, it's the same process. Separate the variables, integrate both sides, and then simplify and isolate y as the subject of the equation. Use the initial conditions, if they're given, to write a specific solution. Thanks for watching.